Hi, my name is Kirtana and my metric number is AA241806. This project explores the concept of how a solid sphere behaves when rolls down on an inclined plane and focuses on how the moment of inertia, which is resistance to rotational motion, affects the sphere movement, acceleration, and energy distribution. So these are the three main challenges in analyzing a rolling sphere. So the first one is coupled translation and rotational motion. The sphere both moves forward and spins. So we need to analyze linear and rotational dynamics together. So the second one is influence of moment of inertia. The sphere mass distribution affects how energy splits between motion and rotation through its moment of inertia. The last one is non-slipping rolling condition. Rolling without slipping imposes a constraint, which is linear and angular acceleration are linked by an equation which is A equals to RA.
My name is Chris Jamin and my metric number is AA240747. So I would like to present the literature review about moment of inertia. So moment of inertia depends on both total mass and mass distribution relative to the axis of rotation. When the greater the mass distant from the axis, the larger the moment of inertia. Moment of inertia links torque and angular acceleration that are essential for rotational dynamics. It is crucial in designing mechanical systems for precise rotational control. For example, rolling objects exhibit combined rotational and translational motion that influenced by moment of inertia. When the gravitational force on an incline increases with slope steepness, it will affect the acceleration of the object. The distribution of mass also determines how easily the object rotates and accelerates.
Assalamualaikum, my name is Kadir Ashraf and now this is the question for our project. As we can see here, there is a solid sphere with mass of 2 kg and the radius of 0.1 meter is released from the rest at the top of an inclined plane of height 1.5 meter at the angle of 30 degree. The sphere rolls down the incline without slipping. And now we're going to calculate the linear velocity of the sphere at the bottom of the incline.
So this is the flowchart of our project implementation. So first of all, we conducted a case study selection discussion, which is moment of inertia. And then we identify the problems. And then we make a literature review of our case study. After that, we did an initial design, then made analysis and calculation to produce the final design for our project. Afterward, the final design, we draw the design by using AutoCAD. Thereafter, we made a design analysis and material selection for our project. Then after doing the analysis, we make improvements. Last but not least, we did a report compilation and presentation of our project.
And now we have the proposed solution. We use 4 methods to find the velocity for the solid sphere to roll down the inclined plane. We use energy conservation, Newton's law and torque, Lagrangian mechanics, and the work energy theorems. For the method 1, we choose conservation of energy. The total mechanical energy at the top is equal to the total kinetic energy at the bottom. So the equation is mass times gravitational acceleration times height equal to 1/2 times mass times velocity square plus 1/2 times I and times omega square. And the final answer for this method, we got 4.59 meter per second. And this is the methods 2, Newton's law and torque. Newton's second law along the incline is mass times gravitational acceleration times sine theta minus force equal to mass times acceleration. And then after the calculation, we got the same speed, which is 4.59 meter per second. And now for the method 3, Lagrangian mechanics. For these methods also got the same speed, which is 4.59 meter per second. And now for the final method, which is work energy theorem. The work done by gravity is equal to change in kinematic energy. And then after the calculation, we got all the same speed for all the method is 4.59 meter per second.
Assalamualaikum and hi, my name is Jazraul Altaf bin Juan Rizal, matrix number AA241341, and now I will continue to the project design stage. The first stage is problem definition. Problem definition is clearly state the physical problem, that is a sphere, solid sphere rolling down an inclined plane. This problem definition identifies the objective, that is to determine the final linear velocity using multiply solution or methods in dynamics. The second stage is literature review. Literature review is study a similar solved problems to guide modeling and calculation of the question. Next, we have a parameter identification. The third stage is identify all required physical quantities such as height, mass, gravity, and also angle. The fourth stage is a method selection, which is in this question we have 4 methods, that is energy conservation, Newton's second law with top, Lagrangian mechanics, and last one, work energy theorem. For the next stage, we have mathematical modeling. Formulate the equation based on each method that we choose. The sixth stage is calculation and simulation. This stage is perform detailed calculation for each method. And the last stage is result interpretation. This stage is analyze and interpret the outcomes of the question and discuss any differences or confirmation between the methods. Either it's right or wrong. Next, we move to the material selection. The first component is rolling ball. The material for the rolling ball is using a steel. The function is the rolling ball act as the main object for rolling motion. The reason is it is durable, consistent shape, and smooth rolling. The second one is inclined plane. The material for inclined plane is rigid plastic. The function is to provide a smooth surface for the sphere to roll down. The reason is it's flat and stable surface and easy to handle. Next, we have ram support. Ram support is made from wooden blocks. The function of the ram is hold the ram at an angle of 30 degrees. The reason is it is strong and stable. We use wooden blocks to allow angle adjustment and reusable. Last one is measuring tools. The material is a plastic ruler and a protector. The function is we use to measure the height and angle accurately to answer the question. The reason is it is lightweight, affordable, provides good accuracy, and it's improved measurement.
My name is Muhammad Fahri Miaskula, metric number AA240370. Now we continue to recommendation for project improvement. To improve the project's accuracy and effectiveness, smoother surface, precise height measurements, and objects with non-shape should be used. Tools like high-speed cameras or photo gates can enhance velocity measurement, keeping the inclined angle consistent. Conducting multiple trials and using software for data analysis will help ensure reliable results. Identifying and minimizing errors like precision and timing inaccuracies is also essential. safety and health issues. Throughout the project, safety and health were prioritized, although the tools used like the inclined plane and solid cone were not dangerous. Precautions were taken to prevent injuries. The setup was placed on a stable surface and the ramp was secured using bolts or clamps. Only one person handled the equipment at a time, while others kept a safe distance. The workspace was kept clean, dry, and free from obstacles to avoid accidents. Even without the use of sharp objects, electricity, or chemicals, basic lead safety practices such as wearing closed shoes and tying back long hair were followed. These measurements ensured the project was completed safely without any accident. For environmental aspect, the environmental impact of this project was minimal due to the use of simple, reusable and eco-friendly materials. No electricity, chemicals, or disposable items were used, resulting in zero waste and no pollution. All equipment was safely stored for future use. The project promotes sustainable learning and serves as a good example on how to conduct experiments with environmental responsibility. For public interest, this project supports education by making complex physics concepts like energy, force and rotation easier to understand through real-life demonstration. Its simple, safe and accessible setup makes it ideal for classrooms, science fairs or home experiments. By encouraging hands-on learning, it helps students stay engaged and can inspire greater interest in STEM fields and related careers. For consequence of action or design solution, choosing a simple and well thought out design was key to the success of this project. It ensures safety, ease of construction and reliable results, avoiding overly complex setups and reliable results. Avoiding overly complex setups and considering factors like friction, balance, and ramp stability help prevent errors or accidents. Careful planning, testing, and measuring were essential to produce accurate data and meaningful conclusions. For a conclusion for this project effectively explore rotational motion and moment of inertia using a solid sphere on an inclined plane. Multiple physics approaches such as energy conservation, Newton's law, and torque were applied and produced consistent results, confirming the final velocity of 4.59 meter per second. The experiment used safe, reusable, and eco-friendly materials, making it low cost and suitable for educational purposes. Safety and environmental aspects were prioritized. Overall, the project demonstrates that hands-on experiment, when carefully planned, are valuable for learning and applying scientific and engineering principles.